All right. Hello, everyone, and welcome to another iteration of the Apache TinkerPop Wide presentation. This is Apache TinkerPop's home on Twitch. These are the presentations where we take a look at some of the community projects that are some of the tools, libraries, graph systems built on the TinkerPop framework. Today, we're going to be taking a look at the recent release of Amazon Neptune 1.3.2. And this is the first version of Neptune to integrate TinkerPop 3.7. Two presenters joining me today here, they need no introduction. They've both been longtime pillars of the TinkerPop community. We have Stephen Millett here, who's been one of the primary contributors of the project from the early days. We've got Kelvin Lawrence as well, who's current PMC chair, the author of Practical Gremlin. So with that, I'll let them take it away and tell us about the new Neptune release.
Thanks, Cole. I think it's nice to talk about Neptune and this particular release because it is the first one to support this TinkerPop 3.7 line, which offers so much new syntax to the Gremlin language that it just kind of almost guarantees that you're going to change how you write something in your Gremlin queries in a day. And maybe even change how you develop your applications a little bit based on some of the syntax. I think we'll see those changes relevant in a couple of ways. In some sense, the new steps offer features that you didn't have before, and they're kind of basic foundational things that you didn't have and just couldn't do with Gremlin. And then on the other side, there's new steps that replace entire Gremlin patterns, which will greatly simplify queries. So, there's a rough summary that I have of those changes. I'm going to need to get the, let's see here, it's on the screen here. And let's see. So there's basically a host of new Gremlin steps, about 26 of them. They help with the support of manipulating strings and collections, dates. And there's new syntax around cardinality and around union step. And I think when you start looking at particularly the new syntax, it kind of begs the question, and as I was showing this notebook here that's connected to Neptune right now to Kelvin earlier, he suggested that, maybe we need to just spend a few moments talking about why some of these steps maybe weren't in Gremlin from the beginning, right? When we look at some of these steps like to upper and trim and maybe substring, right? These are things that are pretty much common to virtually every query language. And so to not have them in Gremlin, you might wonder why we didn't have those things. And I think to address that, I think the answer basically starts with where Gremlin historically sat, in that it originally was built out of and relied pretty heavily on Groovy as as part of it, and the Groovy programming language gave us things like and later Java gave us Lambda functions, closures. And we were able to use those to do a lot of these kinds of operations, right? If you wanted to trim a string, you didn't need a Gremlin step necessarily to do that. You just simply used Groovy, or you simply used Java inside of a closure. But as Gremlin went deeper into TinkerPop 3, we ended up kind of relying less on Groovy for a lot of things. I mean, that was kind of one of the things that happened with 3, is that we looked for ways to try to get rid of closures for a number of reasons. They aren't portable. You can't. They may not work for every graph. They don't work well in remoting situations, and so they kind of only work for certain cases. They can be a security problem. They have a lot of things kind of working against them. So all along we've been looking for ways to make it so that Gremlin could kind of stand on its own in these areas. And now with the addition of these new steps, we make that a whole lot more possible for you to do all the sorts of things that you would normally do. That and you would expect from like other query languages and things. I don't know, Kelvin, is that kind of about the right answer to the question you posed?
Yeah, I think so. I think it's neat that Gremlin is evolving as sort of the use cases in the industry are evolving, and we see more and more sort of hosted type scenarios where perhaps Gremlin's being used more as a language rather than as a complete implementation. So it's nice that the language itself is evolving. And I think we should probably, thank folks watching and others who give us JIRAs and give us feedback and kind of tell us these are the features that they're looking for, and that certainly helps the TinkerPop community, grow Gremlin in a way that the community finds beneficial. So hopefully people watching will go try these features. Let us know in the chat even what you think, because we're pretty excited. I mean, Stephen, you know me. How many years have we known each other? I've been complaining I can't join two strings together. Right?
Yeah, I know it. And I think this made the 3.7 release is and a lot of work done by Yang and Cole and Valentine and others. I think that that helped bring this 3.7 together the way it did to like kind of answer your wishes there, the way that like merge helped Dave in his wishes for being able to easily do get or create type operations. So, but yeah, these foundational questions, these foundational steps were always things that we always had to talk around whenever we were talking about Gremlin, right? They were always things that you had to kind of explain that you have to do in a slightly different way than you would maybe expect. So let's dive into a few of these. I think we're not going to go into all of these steps because there's a lot, and I think most people will know these just from just general programming. These things are pretty well recognizable. I mean, case in point is to upper. Being able to uppercase a string is pretty simple now. Here we get 5 vertices and pop off the city value and uppercase that. Let me just run that for the sake of running. Yeah, we can see we get some of those. So that's pretty straightforward. I think this next one is kind of interesting too. I thought this split is a kind of an interesting step. We often, you have a string and you want to split it by some delimiter. You weren't able to do that in Gremlin, and now you can. So here's one where we split the description property by a space, and what that does is it will return each of those descriptions here as a list. So now you could continue to process that list in Gremlin some way. So I think I think the split step is kind of a neat one that was missing from Gremlin. Going a little further down, let's see. I think this one also kind of takes split and shows another aspect of using these steps. So here we do the same split operation, and then we follow along to uppercase each of the items in the list. So you can see here the use of the local scope on to upper, so that it operates on the list of values and uppercases the list inside of the current traverser, and gives you this output here. And one of the things that I think this is showing, right, is that again we go back to the history, is like, what would you have to do if you had this, if you didn't have these steps, right? You would typically in Gremlin you would have to either use a lambda, which you couldn't always do, particularly with Neptune, right? We don't, Neptune doesn't support that functionality, and so you'd be left to bring that description property value back to your application, make it run the split there and get your answer, which I think works, but it might put you in a situation where you're left to, if you wanted to continue to use that in your query in some way, you would be forced to make maybe a second query. You'd be, have to break it up. Having it here just natively in Gremlin, really could change how some of your queries are written today and how some of your applications are written today, just as a result of having these features built here. Here's a slightly more advanced kind of one where we use, and by the way, the scope option is available on all these steps. So that's what I only demonstrate it once here for 2-upper, but pretty much all these steps can operate on the value in the stream or within the value of a particular traverser. This example groups airports by the first letter of their code, and we do that using this substring thing. And I think this is like another common one that people try to do in Gremlin. You just can't. And so you can see we basically group count based on the first value, then deconstruct the resulting map of the code, the single letter of the code, and the count, and then filter on those to find only those with more than one value. So we can do stuff like that now, which is really, really nice. Kelvin was good enough to point out the join two strings together thing, which is something everybody you always find a need for. You do that with concat. So here's a concat example where we just kind of put a period on the end of the description. And then I think maybe one of the more powerful ones here is being able to kind of template a little bit with Gremlin. So I have 2 examples of that to demonstrate some of the flexibility here. The first is this kind of simple one where you do we grab 5 vertices and we're going to format them into a string. And it uses this sort of templating syntax where you can specify the property values that are in or the property keys that are with in that particular vertex, in this case, code and runways. So we can simply run this and we'll see that there are, there we go. And you can see it produces a string like that. So, you can concatenate quickly. You can do more advanced things with format. But again, it's just showing like this basic operations that, you're probably doing in your application code that you can just simply now do in Gremlin. This example is a little more advanced with format. You can also supply like a variable sort of inside of the format string, template string, and that gets bound to a by operator similar to how MathStep works. So here we're basically getting all the IAD airport vertices, formatting them into a string, grabbing the description property value for this part, and then having this open variable for this part. And that variable then gets bound to this by operator, which executes an outward navigation and grabs the edges and counts up the route edges and puts them into the string. So that's kind of nice. So that's kind of like I just think some of the key, just some of the key steps. I think, again, these are not like new groundbreaking things. They're only groundbreaking in the sense that they are, kind of things that probably are that you use every day and are normally found in common query languages. And now they're in Gremlin, which is really cool. So then moving on to like collections, I think, again, these should recognize a lot of these. There's some filtering type steps with any and all. And then you have different set type operations with, like intersect and intercept and intersect and difference and so on. I put a couple of those examples here for just basic things like combine, where we combine two lists together. So here we have all of the runways in Texas, and that's folded into a list, and then we combine that list with this constant value here of 100. I don't know how many times I've needed to do something like that, and it's always a little tricky to do it. And now we can just do it directly with one step. Similar thing here. This is kind of similar to the example I made with scope, where all of the string functions have that scope argument that allow them to work in a similar fashion. Here we also have the ability to use a traversal to select the list to combine with the other list. So here we create a side effect of X and give it this list value, and do basically the same traversal as before, and then combine the value of that X into that. So we're going to get basically the same thing, but here you can see that you can do it dynamically. And that's probably maybe one of the more powerful ways you might be able to use all of these steps, is to be able to use them, because very often you'll have aggregated something into a list in one place, produced a different list somewhere else, and need those two things to be squished back together again. So combine helps you do that. We do have some basic set operations like I alluded to earlier there. Here's the example with intersect. Again, pretty straightforward in what he's doing. We grab all of the IAD, grab IAD and then all of the outbound routes, and then you fold those codes all together, and then do an intersect with those codes against these. And you can see that leaves us with just MIA and SFO. And a similar thing here with difference. And so we did the difference between MIA, DAY, and LEX, and that leaves us with against MIA and SFO, and that leaves us with DAY and LEX. Here's kind of a neat example where I talked earlier about patterns, right? And how you'll be able to eliminate certain query patterns, which we've put out over the years and developed. When we didn't have these base operations, these foundational operations, we needed ways to allow folks to do certain things, right? And so we came up with ways to do them with existing steps. And with a trained eye, you can almost always notice where those patterns are and what those patterns means. But it does make your Gremlin harder to read. It does require a more expert view when reading a complex Gremlin statement. So it's nice to have these things as they are, just named as they are, right? So in this case, we're finding cities with airports having more than one airport, and where every airport has more than two runways. And it's that kind of second part there after the and that was always a little tricky to do with Gremlin. So now we can just do something like this, right? We can just express the and pretty clearly, right? You can look at this and immediately kind of see that we're doing, the first part of that and here, where we're counting up all of those things and making sure that there's more than one airport in that city. And then we can see the second part of that, where the values are all greater than 2, right? Has more than 2 runways. So we have this nice all operator here now, this nice all step that can do that filtering for us to validate that list is a certain type of way. In 3.7, you had to do something pretty complicated to get that. And let's just run this just so we have the output there. or maybe I shouldn't, so that we can see see them still side by side. Is there a hotkey to clear these, Kelvin?
Yeah, the O key will hide the cell. If you get it.
Okay. Okay.
Just O, yeah.
There we go. Excellent. Okay, and then so you can see the difference, right? So here, the and is all good up to this point, and then when we look at the all part, you have to do this sort of complicated comparison where you label the values with two separate keys, compare them with where, do some bimodulation and some other things in order to validate that the counts of those two things are the same thing. So yeah, we basically replace 4 or 5 lines of code there with just a simple call to all, which is much more readable and easy. So, if you have this kind of pattern and perhaps other ones, you want to look for ways in 3.7 to replace those things and simplify a great deal. I think this is another great example. I think I've wanted this one for years, the ability to merge 2 maps. You deal so much with maps in Gremlin. They're just one of the core things that you produce. So many steps like generate them from value map to element map to select to project and so on. So you always end up with this type, and there was really no way to take 2 of them and put them together very easily. You can see now it's just merge, right? This is like really straightforward, easy to understand. You value map, that gets you a map, and then you can just merge in some constant, in this case x10. It can be a dynamic value like we talked about earlier and saw earlier, where you just can take a traversal. So if you had 2 value maps, for example, you could smash those 2 together and produce a single output. You can see how much more complicated it is to do that in Gremlin. It isn't, again, I sort of recognize the pattern. Anytime I see an unfold group by following a map, a lot of times I just immediately think, okay, we're destructuring the map here, or just destructuring a map here for the purpose of shoving it all back together again. So basically, we union together that constant x10 and take that value map and then unfold all those to group those back together. It works really nicely, but again, it's much harder to read and to follow. I think this is a nice use case here. This for conjoin, where we can get like tab delimited output for results. So if you have a value map and we take that, and we can use this conjoin operation to produce some. Oh, press the wrong one. Here we go. Now we can just get some tab delimited output, which you can copy and paste and do something with. So that can be helpful. Not a lot to say about dates. We have 3 date functions essentially on top of the ability to create just date times in Gremlin. That was pretty much all we had. It was like that date time function. And now there's actual operators to do stuff on dates, which is always helpful. But you can see them at work here, where you can convert a string to a date object, do some sort of date manipulation here. We're going to add 7 days and then do a difference based on this time here to get us some result. I think this is like a really useful one, obviously, because this is a situation where you were usually left to definitely bring data back into your application, or store the data in a way, store your date in a long, so that you could do some kind of basic math operations or something, which was, a way to do it, but also, hurt the ability to, understand exactly what the query was doing. Whereas calling a function as simple as date add is a whole lot more straightforward to understand than doing a math operation or something along those lines that you might have to read into a little bit more. This one here is particularly useful for Neptune. So I did these basically just as text, just to demonstrate, because they do like modify the database and stuff. But one of the things we noticed when we got merge V and E working with Neptune was that Neptune uses a cardinality a default cardinality that's a little different than what TinkerPop does. TinkerPop generally assumes, most providers tend to assume a cardinality single for their properties, whereas Neptune is it list? Or am I going to say that wrong? Is it set? Neptune's for is it list or set? I can't remember.
Set.
Set. Thank you. And so the merge V didn't work terribly well in that scenario because it didn't take into account when creating those, when describing the map that would be given as an argument to merge V. It had no way to set the cardinality, and so we, like as before, we kind of mentioned in previous things, we came up with patterns to kind of deal with that. One of them was this. One approach here is this side effect approach, which you can see here, where on a match, you run a side effect to set the property where you can call single and set the age and or call set or whatever and what have you, and then return this kind of dummy. I guess it didn't have to be a dummy, but a dummy map to satisfy the argument that was required to option. So that sort of takes the niceness of what merge V and E were supposed to be about, and I guess it's just merge V since there's no multi-properties for edges. So yeah, technically this is a little bit of a misprint there. We should delete that. But in any case, what we did in 3.7 was change the syntax so that you could specify the cardinality directly in the map. So this big blob of Gremlin here with side effects and all these property declarations essentially boils down to this single map declaration, which is a whole lot nicer, right? We can just say single or set. There's actually another syntax that allows you to set the cardinality as a default for like the whole map. So you could call it that way. If everything you had was single and you didn't have any set, you could just set it once. You wouldn't have to wrap all of your values inside of that. So that should be a really nice improvement for folks using Neptune. And then I think this last piece was the last piece of syntactical change was having to use union or promoting union to a start step. So now you can just do g.union and put whatever whatever subtraversals you had inside of that. You could always do that again before prior to 3.7, but you have to do this sort of g.inject first. So you had something like this 0 or a true or some other value to kick off the traversal, and then union could just ignore whatever that was and produce this produce the union from that. So that should help. That's an easy one. Find all your g.injects and get rid of that inject start step and make your Gremlin a little bit nicer to look at. So that's kind of the overview of all the changes that are there. Again, I think it's really excited to see this in Neptune. Excited to start getting to get the feedback from folks using it to see how this is changing the way they're writing their Gremlin and hopefully being helpful in making their applications a little easier to to develop. I don't know, Kelvin, do you have anything else to add towards for any of this?
I don't think so. I think you did nice coverage of what we've done there. I definitely encourage people, whether you're using Neptune or you're just using Gremlin somewhere else, but you've got access to 3.7, I would encourage you to get familiar with these new steps and features, because it certainly does make the queries easier. And I think, Stephen, in some places you showed us there was a workaround before, but in many cases there was no workaround. Even if you were, really, really good at writing Gremlin, there just was no way to access a string or something like that. So this is really making life easier and avoiding round tripping, doing multiple queries for something that you can now do in one. So yeah, really looking forward to using it myself, and hopefully other people will find it valuable.
Yeah. Okay.
Yeah, I want to give a bit more perspective on that too, because for me, I'm somewhat a bit newer to Gremlin. I started using Gremlin right around the time 3.6 came out. So a lot of these old patterns that I didn't have to learn like of it. So seeing how much easier it is to get in now, I think is just really fantastic, and I'm excited the direction that the language has been going here.
Cool. Okay. Well, I don't see. I don't think there's any questions. I think this is a pretty straightforward presentation of things, and 3.7's been out for a little while, but I think it was important to kind of note Neptune's support of it, and particularly certain things like the cardinality syntax, which I think I think some folks are going to be definitely editing their code for that one. But yeah, it was good to kind of talk about this a little bit and showcase some of the steps and the perspective around them.
Yeah, so I guess if there's no other questions in chat here, I'm not seeing anything in Discord as well. Yeah, so thanks everyone for joining. Thanks Stephen and Kelvin for presenting here. Yeah, really exciting to see all this coming into Neptune. So thanks for joining, and have a great day, everyone.
All right, thanks, Cole. Take care.
Take care.